Thank you. I want to talk about three things today. One, I'll give a bit of background on the CRC for spatial information, just to give some context to where I'm from, and also present, I guess, a framework for the views that I'm about to let you know about. Second thing I want to talk about is to really just reinforce some of the industry trends which we've heard about today. I think we keep an eye on those through our partners, and they're very consistent. What I'm about to present is very consistent with what you've seen already. So I think industry and government are getting, I guess, a good picture of what the trends are in our industry and how we are changing over the next 5 to 10 years. Third thing is I think I'll talk about some of our projects, specifically some of our collaborative research projects that have national significance in our country, and some of which are being applied throughout the region. So let's get rolling. I guess just to talk a little bit about what we are. We're a research centre. We're a collaborative research centre, and we're made up of many partners. So we're effectively a joint venture of government, industry, and academic institutions. Our core business really is multi-year, multi-partner projects that run either from 3 months to 3 years typically, and at any one time we run between 40 and 50 projects. So these are within an overall program. I'll talk a little bit about that later on, so I'm just going to present 3 or 4 of those today. And really our overall aim is certainly in Australia and New Zealand is about building better capability in our spatial companies and organisations, building a better awareness throughout Australia and New Zealand for the use of spatial information and promote that. And also we have a training role and also I guess a mandate to help all our companies that we're involved in with research and development. So that's really our focus. So just to give you a quick look at our partners, our partner base is a number of academic institutions in Australia. Effectively it's made up of the Australian land and mapping agencies, and also some key users of information in government, agriculture, natural resources, health and defence. And we also have a significant number of international linkages where we participate in projects with a number of partners, certainly some in the region, and also in the US and in Europe. So you'll recognise a few of those logos. These are the companies that we work with in Australia and around the world. You would have seen some of them are here today. We work predominantly with companies that are involved in geospatial integration, aerial acquisition, or any sort of sensor survey and positioning, device and equipment manufacturers and distributors, and a number of IT consultants. So I'll talk a little bit about how they're involved in our projects as well. To talk about the trends, well, I'm really going to present it in our research framework, which I'll show a little bit later on, but we spend a lot of time looking at, in the positioning world, looking at the increase in infrastructure that's occurring globally. So just as another example, recently we heard about Korea is about to put in a regional satellite system. We heard India is about to roll out a continuous operating reference station network right across its 3 million square kilometres. So significant infrastructure, as well as the ones which are already in the press around the increase in Beidou satellites, the QZSS system in Japan, looking to put some more satellites in the air as well, so in the sky. So significant growth in the positioning industry is occurring. We heard earlier today that world growth forecasts are around 2 to 3%. In this region it's 5 to 6%. In Australia it's around 2 to 3% over the next few years. Well, in the geospatial market, as you'll see some of the numbers that I'm about to put up, it's consistently higher than that. So this industry is growing at a greater rate and has been growing at a greater rate for the last 10 years and will continue to do so for the next 10. So this industry is growing based on a number of drivers, which I'll talk about shortly. So a couple of others that aren't up there is also I guess the mobile market. We've heard a little bit about that today. Also the indoor market is about to take off. I think we're seeing some of the major search players, especially Google and Apple, invest heavily in indoor positioning and location technologies to drive their businesses. That'll be occurring more and more, and you'll see a lot more around that. Real-time traffic, for example, is now an embedded technology in most of our mobile apps. So these changes in mobile and applications, as are already discussed, are going to continue. When I look in the sensing area, we've already heard today, massive amounts of LiDAR data being collected, laser scanning, both mobile mapping and aerial. Again, satellites more being launched continuously. The launch forecast is significant for the next 10 to 15 years. If you to believe the current sort of estimates. Again, similar sort of growth area in the sales of satellite imagery globally. Radar is starting to pick up in sales significantly now, represents 17% globally. That's going to be a growth area. We've heard about UAVs, and each conference I come to, you seem to see more in UAVs. We're seeing those operationalised now in Australia, being used on a number of sites where they're actually right through the workflows, picking up aerial information and feeding that back to managers. So that is a product which is mature in certain countries, and will explode when we can get our, I guess, the sensor platforms a little smaller. I guess combining that with the service industry, again we're seeing some big numbers on growth there, consistently growing. What we're seeing is now a trend towards, I guess, taking data from sensor platforms, incorporating it into business in a near real-time sense or a real-time sense. And when you're dealing with LiDAR data, or you're dealing with large amounts of satellite imagery data, we still haven't got there yet on how to move that data around and how to I guess, search, discover, process and query that in a near real-time or real-time context. I think that's coming. We're seeing better use of supercomputers now. We're seeing more specific algorithms to drive integration of data and process that data so that you can look at that in near real time, and then also look at that temporally. So how do you look back on a vast set of satellite data over many years, have a look at the same area and do that quickly without having to move a whole lot of hard drives? So that's where the next steps are in the next few years, is how do you actually integrate different satellite data sources, temporally examine them and draw a conclusion from them, all doing that over the internet. So the growth is going to be around processing tools, querying tools, and understanding how to process them on the supercomputing infrastructure that exists around the world. So we're definitely going to see a lot more in that area. Our view is also the health market is one that's going to is going to pick up significantly. It's an area that is, I guess, under GIS, for want of a better term, and there's significant gains in this industry to be seen just by implementing, I guess, the current state of technology. We see some numbers on this that a lot of the health data that's been collected, really 30% of it apparently is not electronically generated, so it's still a manual process, and that's even in some of the leading edge health markets. So I think this is an industry that's worth watching. Just on this trend, the integration of data in Australia, at least, different data sources is becoming a significant growth area. So we're seeing now data. We're seeing data from credit card companies hooked up with the standard demographic data, hooked up with some of the spatial data sets that government provide, across loyalty programs, and then consumer profiles being built. This is the next, I guess, next step. So already it's driving standard advertising where profiles are built up based on gathering certain credit cards companies' data and then looking across that, combining those data and then targeting I guess, advertising. We're seeing it go another level where they're building individual customer and consumer profiles and using that information in a more intelligent way. This is definitely, certainly in an Australian context, and looking at some of the work that some of the Australian chains are doing in the US is going to be a big area in the next 5 years. I've certainly seen some results where one of our large chains, Westfield, is working in the US in using visual tracking technologies to look at cars, combining that with individual consumer information as they enter the stores, and looking at building profiles on how long they're there, where they're spending their money, and then using that in marketing. So these are significant trends. Health again, bringing in data from standard apps. We've seen, if you just pick up your phone, a lot of people use Runkeeper, Map My Run, Strava, all these sort of applications. That data is being fed back, used by those companies, combined with other sources of information to provide, I guess, predictive and analytics. So we're seeing this trend in geoservices hit more broadly in the consumer area. This is just, I guess, a summary from the CRC's perspective of a number of areas. I won't talk through these now, but I will talk about the policy drivers briefly. Certainly in Australia, there's a drive for open source and open access of data. There's a definite trend right now in government outsourcing. Australia is very embryonic in its space policy. That's likely to increase, and the Australian government is rolling out a broadband infrastructure. So these policy drivers combined with the technology drivers definitely mean the integration of information is more facilitative now than it has been in the past. Let me briefly talk about our research, I guess, platform. We work across this outer ring is an application area, so health, defence, energy, agriculture, sustainable urban development are our core application areas. We have capabilities in positioning, information generation and spatial infrastructures. I'll walk briefly through some of the research and where we're at. This is a national. I borrowed this slide. It's a technological slide, but what I'm trying to illustrate here is our research endeavours in the positioning area. So we're very much interested in improving atmospheric or ionospheric modelling, improving the clock and orbit models from satellites, and using that to drive out a better accuracy. That's where our research is focused at the moment. Why are we doing that? Well, we're interested in improving Australia's national positioning infrastructure, which effectively consists of all the satellite work, the ground-based and satellite-based augmentation systems. We have a heavy emphasis in continuous operating reference systems, which I'll talk about in a minute. And so our aim here is really to provide research that assists to roll out Australia's national positioning infrastructure, which is a national initiative driven by the federal government. Just to give you an idea of at a reference station level, I won't dwell on this slide too much, but if you look at the right-hand side, this is where our infrastructure, the reference station infrastructure currently operates. So in Australia, that's across the majority of the, I guess, agricultural area and in the country. However, there's a significant amount of gap there. We're trying to work out how we I guess, economically fill that gap with different technologies. That's one of our core research areas at the moment. Just to give you a quick set of results, we're working very much on integrating different signals. The research groups that operate in our research organisation have some world firsts in this area. We're getting pretty good at integrating different signals. What does this mean? Well, it gives us some alternative pathways to more accurate positioning, more comprehensive current signals, and potentially opens the door to I guess more applications, which is the aim of the game from our end. Just to talk a little bit about one of our other national initiatives, and I'll just go back. This is in effectively just picking one project out of our second research area, which is our information generation area. I haven't got a picture of Australia in this, but I'll use this one. So we're building basically, or been assisting to build a national elevation data framework. What that's been driven by at the moment is the climate change agenda, and effectively we've flown a coastal LiDAR from effectively about here, right around the coast, to about here, which covers the majority of the Australian population. So we have right up to the 10 metre contour a consistent now map of the country based on LiDAR, and that's about 120 to 150,000 square kilometres of LiDAR just on that strip alone. There's a significant amount of LiDAR in Australia being flown at the moment. Which I guess brings me on to one of my earlier points. How do we, temporarily examine different LiDAR sets for changes quickly? That's another emerging area of research, and something that I think globally will be necessary in 10 or so years' time when we have a temporal record of LiDAR data sets to examine. So just coming back to this, the framework, we've effectively collected that data. Why? So we can provide this data, make it available to model climate change and look at sea level rise. It's about a coordinated national approach. Make that data available across all governments. Serve it up via a portal. Develop tools that allow those products to be used, and also it's also about developing guidelines that look at consistent quality and collection of data. This particular initiative has involved a significant number of companies in the acquisition, the processing data, the serving up of the data, and the financing. So it's been quite a large project. And where is it at the moment? Well, it's been picked up by our major mapping agency, and they continue to build that portal, deposit Commonwealth data into that, and use it for dissemination. It's also feeding into the national. We have a national digital elevation model which is provided. We're using the LiDAR data and other sources of elevation data to improve that. So we feed the LiDAR data in and basically improve that model, which is originally derived from the SRTM. Another project I briefly wanted to talk about was we extending that LiDAR work into the Pacific. So we've done some work with our government, which is around Papua New Guinea, Tonga, Samoa, and Vanuatu. That's been a partnership with a number of Australian companies and government to look at taking that data and providing it in country, and training up people to use that for sea level rise and other planning purposes. So that's a continuing project and involves a number of our core partners. Just to give you an idea of some of the products which we've pulled out of that data collection. I'll just go back. These have been provided by us, by our providers, and us to the countries at the moment. And currently, we're going through a training program to have that upskilling. Just quickly to finish off, I'll talk about a couple of other projects we've been involved in around elevation models. We've worked in Papua New Guinea using airborne radar data to develop data sets and provide those back to the PNG government. We're working in particular in climate change. We have some field sites that's a picture of Tasmania. We're working with setting up, I guess, a monitoring and reporting and verification techniques to contribute to the world effort on monitoring climate change. So that's been a key initiative of ours, together with CSIRO, one of the National Research Agency for Australia. Just to touch on one other project, I talked a little bit about health earlier. We've been doing some work in Western Australia. We'll come back. Doing some work in Western Australia around improved analysis of population and in particular locating treatment centres based on cancer incidents, not necessarily on demographics, but on health incidents and cancer incidents, and then. We're looking to take that to. We've recently set up a partnership with a similar organisation in Sweden, and we're looking to take that, across to Europe as well, and work in partnership with those guys. Just to talk a little bit about what we see as the challenges. I think these are applicable to this industry, to this region as well. It's definitely all the presentations you'll see today, tomorrow, indicate that the industry is continually changing. It's becoming more consumer, influenced, and it's becoming more mainstream with the IT industry. We're seeing more outsourcing. We're seeing more open access. That will continue. and we've already seen the rapid rise of the web services, and that will continue as well. Certainly, in Asia and in Australia, there's definitely a skilled capacity gap. We're seeing it. We're seeing people drawn more from the mainstream IT and being spatially skilled up. I think the decline in the number of spatial people on the market at the moment is a very, very big concern for the industry, and I think that applies in this country as well. In Australia, we're also seeing government heavily involved in Earth observation and positioning. We think we need a better understanding of their future plans around those infrastructures to guide industry, and certainly we need clear intentions in our country to allow investment decisions to be made as well. So I'll leave it there. Thank you.